Welcome to the class dedicated to creativity and innovation across domains. We've been talking very much in general terms when we looked at creativity and innovation through the course, but obviously and at different times we became aware that we can't really speak of creativity in general. Creativity depends on the domain of activity, depends on the task you're doing, and even on the person performing the activity. The creative process will always be a bit different. So the big question for today's class and the week we're in is actually what are the similarities and differences in creative expression across different domains. To understand that, it's nice to go back again to history and look at the figure of someone like Leonardo da Vinci. He was a true Renaissance man. Leonardo was a painter, sculptor, architect, musician, mathematician, engineer, inventor, anatomist, geologist, cartographer, botanist, and writer. So obviously he was a creative genius in a variety of domains, even if he didn't make genius level contributions or historical contributions to all of these domains. He still remained a pretty impressive artist and even scientist. Can this happen today? Can people be creative in a variety of domains? This is a very interesting question because it does reveal whether we assume that creativity has a domain general kind of factor to it that would allow, if someone is creative when doing math, he or she would be expected to maybe be creative in poetry or when cooking a meal. On the other hand, we can think in terms of domain specificity and therefore acknowledge that someone who is a good creative mathematician might not be a good poet or a creative poet, which indeed is often the case. So the debate between domain generality and domain specificity is quite present in creativity research, and there have been people who argued for both sides, that creativity is more domain general or more domain specific. The former generally looks for a general factor of creativity, which is similar to when we talk about intelligence, that we want to measure IQ as a unitary kind of construct. And this general factor, for instance, could be divergent thinking, that you need to be able to think divergently across domains, whether you're a mathematician, an artist, a designer, a cook, and so on. But the latter approach actually focuses our attention on what is specific and contextual within creativity. So, for instance, having a certain kind of knowledge, specific knowledge, domain specific knowledge, is very important. You can't be a very successful, highly successful mathematician without knowing math, and that does take a lot of time. So, equally, if you want to be a great poet, creative poet, you would need a new type of knowledge, a new type of training, and a new type of skill. But obviously, instead of dichotomizing too much these two poles, we can also think that creativity could be, in fact, both general and specific. And this is what a theory like the amusement park theory proposed by Kaufman and Bayer actually comes into play. So you have different, in the amusement park, and it's quite a funny name, you have a set of initial requirements to enter the amusement park of creativity. You need to, well, in a normal park, you would buy a ticket, pay with money and so on. But in the apt model, you actually have intelligence, motivation, whatever environmental influences that allow you to be creative. Within the park, you have to choose a general thematic theme, then you have to focus on a domain and very often a micro domain within it. So the general thematic theme in a metaphorical way would be, what would you like to do in an amusement park? You would like to go on rides, you would like to pet animals, you would like to hang out with cartoon characters. What is the general theme? Yeah. So for instance, in creativity, you can think about the fact that you have different areas like math and science on the one hand, artistic creativity on the other. This is a general thematic area. The domains is actually picking the amusement park itself, right? So if you want many rides, you're going to go into a certain kind of amusement park as compared to another. Going back to our example of domains, if you are a creative scientist, you have to specify whether you are in chemistry or biology or physics or psychology or whatever other domain. There are very few Nobel laureates and winners who actually make contributions to more than one domain. I think Marie Curie is one of the big exceptions. And then you have the microdomains. Within the actual park that you get to visit, where would you go? What ride in particular would you go on? So if you are a psychologist and you're a creative psychologist, you probably will be either clinical, cognitive, social, developmental, or any other particular microdomain within creativity. So what the apt model, the amusement park theory, makes us aware of is that there will always be some elements of communality due to the general thematic area. So it'd be much easier perhaps to be creative within artistic creativity, both maybe within photography and painting, because they're a bit more related as domains, than between painting and solving equations, although some people do that too. And then you have to pay attention to specificity and context through the domain, and especially through the microdomain. And we can go even further and think about creative tasks and activities that are more particular. So if you think of domains, we have to ask which domains, and how many are there? Gardner, who is one of the fathers of multiple intelligences, he related domains to different types of intelligence. So there is an intrapersonal, an interpersonal, and mathematical, and linguistic domain, and kinesthetic, and different domains of creativity aligned along types of intelligence. Feist and others define domains differently as physical, social, emotional, natural history, language, math, art, music. And for many people, domains are actually what is institutionalized. So if you look at school, you have disciplines, and these are domains, basically, of creativity. It's important to notice that most of the literature focuses our attention on certain types of domains, so especially the arts and sciences, and kind of ignores other areas, and especially a big area, which is the creativity of everyday life, a topic we're going to come back to talk about through the course. But if we are to focus a little bit on art and science as these two almost polar examples, I will want to bring to your attention a study that I was part of. I worked with colleagues from France. It was called CreaPro, and it studied the creative process in 5 different domains: art, design, science, music, and screenplay writing. For the purpose of this discussion, to keep it as a short video, I'm going to just compare art and science. We included interviews with established creators within each domain, and we also had questionnaires and a diary method for students. I'm not going to get into more details. I think you have a reading this week precisely about this. Then what we looked at was 12 artists and 12 scientists, so painters, sculptors, visual artists in the art sample, physicians, mathematicians, ICT specialists, chemists in the science one, physicists, excuse me. So findings from art and science, if we look at impulse, what drives people to be creative in a certain area of art. Artists talk very often about the need to make or create, to do, to incarnate things, which is a beautiful metaphorical way. The work is alimented by curiosity, to see and understand, to find sensations, and the need to express, what some people call the narrative desire. And this all creating in all this becomes a physical necessity. It's not only a psychological impulse, but a physical necessity. What about scientists? Well, they talked often about the need to solve or find an answer to a problem or question and to learn something new. So great curiosity was a big engine in science, and clearly it was in art as well, but scientists really talk about the passion and the need to know, the epistemic motivation to engage in creativity. They also wanted to advance their domain, to obtain new results, so this view of progressive, the progress of science. In art, different obstacles artists were faced with: the incapacity to visualize and reach a creative idea, missing the necessary tools, the failure of the material support. They couldn't do it with the tools they had. Artistic activity involves a series of crises for many: self-doubt, the desire to burn everything down and start everything afresh. In science, incomprehension is a big obstacle. You can't solve it. You can't even begin to understand the problem you're dealing with. a feeling of being blocked, incapable to continue, and depending on the area, you also have the missing mathematical tools or technology or complexity of it that you have to overcome. You don't know how to use the technology you have. If you look at the actual actions of an artist, what do artists do? They often start from a vision, a general idea of what their creation is about. And they go through moments of reflecting, of researching and incubating, waiting for the idea to mature, and then they fabricate. They do a lot of sketches, they start making drafts. Often they create a series of prototypes and so on. So the movement of art is a bit messy. It goes from reflection to reflection to action again to waiting, non-action, and then plenty of action. This is actually a quote from one of the participants. In science, you always start with documentation because you need to know what happened before. You need to know what is the state of the art. And then there is a relationship between theorizing and conducting experiments. And this relationship varies according to the type of science. In astrophysics, it will be different than in chemistry and physics and so on. So one quote is that in science, there is the obsessive period, there is the enlightened period, and a period when you sweat hard to put things into shape. So basically, we go back to what you remember from Wallace's stages of the creative process: preparation, then illumination, the enlightened period, and then verification, implementing ideas. Finally, if we look at undergoing, which doing means acting, undergoing means perceiving, taking in. What do artists take in? As they work, they say that the first stage is life. It's from life that they get their ideas and inspiration. And it's very physical, sensorial, the sensible presence of the work, the confrontation with the work. That is what they're trying to perceive as they create. Objects can guide and they ask a question. Remember also the class we have on materiality and creativity. And others can serve as a kind of a third eye on the work of art. So they can give an external view to what's being created. In science, you have, of course, what you undergo, what you perceive is, first of all, you do an enormous library work, going back to preparing for for creating. Colleagues are very important because they pose problems, they formulate ideas, they orient the work, and finally, they're the ones who evaluate it. And as a quote from a scientist, the phenomenon itself imposes incredible constraints. So another thing you undergo is the resistance of what you're actually studying. So what are the similarities and differences across art and science? I think by now you already saw that they both exist. First of all, the motivations to create differ a little bit. For artists, very often it is creating itself, the making that is very motivating, expression, self-expression. For science, very often it is the need to solve, to know, and it's basically curiosity. Similar obstacles across the range: incomprehension, the fact that you don't understand, you're missing the tools, you cannot use the tools you have. This is what both scientists and artists are confronted with. In the way they go about their activity, there is a cycle of going from ideas to working and then ideas again. But it tends to begin and end in a bit of different places. In art, very often the artist starts with a kind of vision that is a bit blurry, uncertain, so that they work it out a bit, they make prototypes, they test it, and then they come up with a new idea. And then the cycle continues. In science, very often, it's the library work, the fact that you need to know the work of others. You need to have a basis, and then you create an idea, and then you do more work to test that idea, and again, the cycle continues. So in terms of material and social aspects, undergoing, as I mentioned, these are mentioned by both, and there is a bit of an emphasis on materiality and art and on the social influence of colleagues and other people in science. But again, it will depend a lot on what Kaufman and Bayer talk about as microdomains. So before we end, I want to take you back, and I mentioned John Dewey before. He had this beautiful intuition about art making. And I think it applies well beyond art. He said art It is a developing process. The artist finds where he is going because of what he has previously done. That is, the original excitation and stir of some contact with the world undergoes successive transformation. The state of the matter he has arrived at sets up demands to be fulfilled, and it institutes a framework that limits further operations. This is what Dewey referred to as the dialogue, the interconnectedness between doing and acting, and undergoing, perceiving, noticing what has been done. And this kind of process, action, perception loops, doing and undergoing, they really cut across the board, whether it is art, science, design, music, everyday life creativity. And many of these you're actually going to get to know more about in the activities and the resources for this class. So summing up, creativity is largely domain specific, which doesn't mean that there are no processes that can be generalized across domains and obstacles and motives and forms of action and so on. The work of artists and scientists displays an interesting pattern of both difference and similarity, and in the end, the way we create across domains is actually cyclical, engaging in cycles of doing and undergoing, in the words of Dewey, acting, standing back, and acting again. This, in many ways, is the nature of creating or innovating.